Hello students and YouTube community. This is Dr. Satish Singhal, PhD, Professor of Computer Science at Community College, California. So this is in the continuing series of 3 lectures. Design example 3, making decision software, part 2 of 3 now. And in part 1, we found out how we can design table of input variables, output variables, analysis, math formula to C++ form conversion, table of Boolean conditions, layering in them, an algorithm executed when certain Boolean condition is true or when it is false. Now, based using them, analysis, input or output as foundation, now we're going to develop the algorithm. And we will point out to you how variable names in input table, their data type, output formatting, analysis in form of C++, form of formula, Boolean conditions, and algorithm under them are being used in developing the algorithm, which will become the foundation for the source code. Okay, so let's go to the algorithm. And we'll go up and down this document to show you why we did certain things in algorithm. Okay, so in algorithm, I want to introduce some abbreviation. EOL will be used for end of line, and this left pointing arrow means that input is being done from keyboard or file. So we're not going to use the words get and store. This arrow will mean it is getting the data and storing it in the variable, which is on the left side of this variable, this arrow. Okay, so this means inputting from keyboard or file the user data into memory location to the left of the arrow. So now in this design example, we want to do scientific output. That will require a C++ flag or whatever flag is there in other languages to do the scientific output. So that's the first step. Notice how I'm doing this document. There are line numbers and there's step-by-step algorithm number. So you have to do that in your own IOA document for lab 3. All the lines have to be numbered, and then inside this step-by-step algorithm, you have to have separate numbering. And then we'll show you how the sub-numbering is done when certain condition, if and else, are checked. Print is used instead of cout, and we do not use those arrow either. So we say welcome to Pythagorean theorem program applied to Euclidean space only. EOL means after this statement is displayed, there will be end of line character, so that next output is on the next line. So you tell user enter your computational choices, H for hypotenuse computation, B for base computation, P for perpendicular computation. And if you remember, in the input table, we had a choice variable right here. That's the one that got declared, and that's the one we are using. I skipped the declaration step because I gave the input table. Input table already gives you those. So, but if you want to include them, that's fine. I have no problem with that. So choice variable is going to store user input that could be either P, H, B, or P. And I do understand that in my table it was uppercase. In algorithm, we are not worrying too much, although we should, about the case sensitivity. Now, this step shows choice equal to 2 upper, pass it to the same variable. 2 upper is actually a function that's available free of any includes, free of cost in C++. So what it does, whatever is passed to the function, if a lowercase letter is passed, 2 upper function converts it to uppercase, not convert locally, but its version, and stores it back. So if user entered like say lowercase h, that would be converted to uppercase h, and that way we can make this next comparison somewhat easier. So we're kind of preventing user error in case they enter the lowercase letter, but we are comparing to uppercase. Okay, so now they could have entered this, this, or this. So corresponding to that, we have 3 if and else blocks. So okay, so I'm only doing one case, and you are supposed to do rest of them yourself, and that's the interest of time. So let's say they entered that they want hypotenuse computation. So we'll use the if statement to do that. If choice equals character h, then. Now notice, I want you to notice this structure of algorithm for if and else. The way it's done, you use the word if. This could be placed in parentheses or not, that's optional. So you could do what you see here, or you could do this. Either one are optional, but the word then is required, and there cannot be anything else in that line. And that's very simply because we want to do sub numbers under that. If I do this 5, so I cannot put 5.1 here. So I have to go to the next line, and it says print input message, end of line. So what was our input message? That was shown in the constant here. All your input must be, that's our input string message. All your input must be positive and non-zero. When we run the program, you'll see that will show up. Okay, so we are using that in algorithm. Okay. Hold on a second. And then since we are doing hypotenuse computation, inside the choice 5, choice h, if they entered h, then obviously we want an value of the base, and we tell them enter the value of base. That's xx.yy simply means they can enter real numbers or whole numbers. Okay, and we store that into base variable that was declared in the input table. You have the document in front of you, you can take a look at that. Echo print base means simply say cout whatever you entered. You will see more in the source code about that. And then they may have entered a negative number, which probably wouldn't matter because we are going to do squaring. But if I was going to compute something else, like say tangent or some other trigonometric function, then it will make a difference. So that's why I do this next step. Base equal to abs of base. Abs is a function in CMath library. My chapter 4 describes that. But basically what it does is, if there is a negative sign that is dropped, and only positive value will be stored. So just take the absolute value of the base. And then we ask for the perpendicular, store that into perpendicular variable, echo print that, and take the absolute value of that. And now remember we did these Boolean conditions. So for example, this was the case. We go to block 3. So let's look at the block 3. It says check the value of the perpendicular and base for 0. Okay, so we might have done something different. Yeah, actually we didn't do that. So if base is 0 or perpendicular, if either is 0 or both are 0, then obviously computation is not possible because we need to compute hypotenuse, which will be requiring non-zero value for that. Okay, so in that case, if base equals 0 or perpendicular equals 0, that means either could be 0 or both could be 0, then we print computation with one or both side with value 0 is not possible, and we tell them please rerun the program with realistic values. That's the part of the same print statement. Now I want to direct students' attention to this layering again. There's a layering here too. So there was a layer that we checked the if condition. Under that there will be program statements. And then there was this layer 5.10 checking this Boolean condition. And under that layer I have a print statement. So notice that how I'm numbering them. If it was 5.1, then I went 5.1, 2, 3, 4 up to 10. But under this layer, then I have 5.10.1. That's the first statement. If I had another one, that would have been 5.10.2. So these layers, this layering structure makes it very clear how the algorithm is written. Layering is required. Not use of layering will deduct points because that makes algorithm harder to read. So you understand this layering structure, use it. Now, if both are non-zero, if base and perpendicular are non-zero, then this condition will be false because equals 0 will not be true, and this condition will be false. If both are false, you know in the if and else, if both conditions are false, or overall if condition is false, then we always go to else block. So this will not be executed, and then else will be executed. So under else, then we are clear that we can use this expression here to compute the hypotenuse, expression 1. Okay, and our Boolean condition analysis also shows that. Use expression 1 to compute hypotenuse and output the results to console. So that's the one we follow now, right in the algorithm. So this variable name was already chosen. So HPIT equal to SQRT function is being called, base into base plus perp into perp, and computer will compute the square root of this expression, store the hypotenuse, and then I use the print statement. This is the literal string. This is the variable that just got computed here, end of line. And then we have end if, signifying that this if or else, this whole structure got ended after this. So notice how we are doing algorithm for if and else. This is the industry standard. You have to learn it. If you don't write it this way, people are not going to understand what you wrote. You have if condition, if word, condition being tested. It could be one condition, it could be two condition, and then you have the word then. Nothing after that, nothing after that. And under that, you have the tasks or algorithmic steps that are being done. Okay. And This one, this is nested inside that. This is confined inside that. So this whole 5.10 structure and 5.11 structure is confined inside that. And then end if means we ended this one, not the outer one. Okay? For outer if, there could be else if now, like this. So if choice was not H or it was B, then we'll do this structure. 6.1 will be enter blah blah blah. This is the string message. This is there in your document. And what then is required? Anytime if or else if condition is tested, no additional words are written in that line. Notice else does not do either. It doesn't test a condition. It doesn't have the word then. Okay? Notice that. That's industry standard. You need to understand that. And what I would like to do, you can read the source code a little bit later and fill out these steps for a practice of writing algorithm for if and else structure. Okay? And I've given them all the way for choice B and then for choice P. So you should do these and get a little bit more practice for writing algorithm for if and else if structure. Okay? So in algorithm we have illustrated fully one case when choice is H, and we are asking you to do other two cases when choice could be base computation or choice could be perpendicular computation, to clarify how and learn how that kind of algorithm is written. Okay, so we'll only do this much in this part, and in the last part, part number 3, we will show you how algorithm is converted into the source code. Okay, so thanks from Dr. Sengal for watching this part 2, and we will very soon meet in part 3.